Good morning, everyone. It's good to see you. A lot of exciting things in store for today. In talking about this and talking about battery manufacturing, this is an industry that has added billions of dollars of investment to Georgia and thousands of jobs for Georgians. So just thrilled to be able to talk about the state of manufacturing, innovation, and other topics related to the growth of this industry here in Georgia. My name is Greg King, and I am the Associate Vice President for Economic Development at Georgia Tech, so just right across the street, so happy to be here. I am joined here today by Jason Peace, the Senior Vice President of Business Development for FREYR Battery. Welcome, Jason. So it's just me and you here, pal. So we'll just get after it.
Oh, it's a fireside.
I know. So tell us a little bit about your career path and what led you to your current role at FREYR.
Yeah, for sure. So unlike Dr. Gaddy, my entire career has been in Georgia. So from start to finish, I started in a small town where Georgia Pacific had a paper plant. And quickly moved to Georgia Tech, engineering degree, went to Emory, worked in various industries within Georgia Pacific, various roles within plants, engineering background, and marketing, product management, supply chain, all kinds of different roles within GP. And then I had the opportunity to jump to Koch, not this Koch, K-O-C-H, Koch Industries, in their investment team. And they had an investment team focused on this green sector, of which we looked at hydrogen, nuclear, batteries, solar, anything in that big that transition space. And spent a year or two there with lots of investments. I think we dropped about $1 billion in various companies in that sector. And one of those was FREYR Battery. I was in charge of site selection for FREYR Battery early on before they actually hired me away. And as being a part of the investment space in that green transition, I just grew to love it. I mean, I had worked in very mature industries of paper, wood products, other things that Georgia Pacific's, known for. But being involved in that green transition, I saw that as the next big thing. And this was the PC era of the 80s and 90s. The pace of growth was kind of encouraging and exciting and wanting to be part of something that the future was going to be. I was excited by that. So I joined FREYR as early on, so employee 2 in the U.S., and like I said, site selection process and really building out the business to make sure we were building things that were appropriate and in line and investable at that point.
Jason, for those who may not be familiar with FREYR, share a little bit about the background of FREYR and so what you do, who are your customers, and your technology.
Yeah. Sure. So we were founded as a New York Stock Exchange listed company in 2021. In its infancy, it was a Norwegian-based company, hence the name, FREYR, with a focus on, we were technology agnostic. Lithium-ion batteries was definitely our focus, but technology agnostic with a particular growth segment in utility-scale energy. Our initial technology selection was a 24M. 24M's the company name. It's an MIT spinoff that makes lithium-ion in a slightly different way, advantaged in certain ways, but still in early stage development. With that, we started building what we call a customer qualification plant, so essentially a very large-scale pilot plant in a northern area of Norway, and we started building a gigaplant in Norway as well. About that time, federal policy here in the U.S., the Inflation Reduction Act specifically, changed the economics. I mean, it changed the world. So economics said the U.S. is supporting this green energy growth, and as a result, we should accelerate our investment in the U.S. So we started going that way pretty quickly. Having said that, we did just produce, actually I just got an email yesterday, our first batteries off of our customer qualification plant leveraging that 24M technology. So we're excited about the idea of having a completely U.S.-made tech stack battery that we can grow into in the future. But where we sit right now is we need to grow fast. The projections for the needs for batteries in the U.S. to support the growth anticipations is we need 120 gigawatt hours of batteries in 2030. That's 6x what we're doing currently. So pretty drastic growth is needed, and as a result, we need to find more mature technologies that have been doing this for a long time. So currently we're looking at other technologies that we can license and bring to the U.S. to help the U.S. get up this curve faster and support the needs of the industry. As far as markets go, EV mobility is certainly a focus. I'll segment it a bit, though, and say EV mobility has a specific type of battery. Utility storage has a different type of battery. Trade-offs being cost versus charge rate, to keep it simplistic. We're focused on the utility scale storage. So those are specific batteries that are safer, cheaper, higher cycle life. They can cycle a lot more often. That's our focus. And as a result, that's really where we're focused. So customers for us would be solar developers, utilities, Georgia Power, we've talked to them, and other utilities around the country to support the needs of the transition. So if you think about the utility space, right, there's vast needs. So if you broke it down into, there's renewables, which, as Dr. Gaddy said earlier, there's the generation time that they work well in, but batteries paired with those kind of span that out. They flatten that curve out. So co-locating battery with solar takes that peak and flattens that curve out so that you can use that energy you've generated for a longer period of time. The other is, as you see more renewables grow in certain areas regionally, the transmission system's not built to support that. So putting batteries in certain areas of the transmission grid kind of act as tanks. So you can store energy there so you're not overloading transmission lines. So that's kind of more on the utility side. And then as you get more into industrial and residential, kind of behind the meter applications to support resiliency and maybe arbitraging pricing if you do real-time pricing, that's another area that would be a focus area for us. So lots of commercial customers and perhaps even residential customers as well.
Jason, it sounds like that there's a large landscape of opportunity. I think there's going to be a lot of great quotes today, and I was thinking about this morning. I think probably the best quote I've heard, I'm going to see if I can make eye contact, but I'm a music major. I count to 4 and then back again. So building on that, we see batteries and we hear about batteries every day. There's household uses for batteries. We know about EV uses for batteries. We see that here in the state, certainly. There are battery facilities that represent household and consumer batteries. There's companies that represent recycling and materials. All of those things are here in Georgia. Give us a battery breakdown, if you will. Kind of break down the types of batteries and why that's important. Just maybe to kind of level set us here as a group.
Yeah. So lithium-ion batteries are nothing new. I mean, they've been used for decades in AA batteries and then more so in phones and laptops. Those were the early use cases. That was when costs were high and those products could absorb those prices, or those cost and prices, therefore. But as innovation has played out in the last few years, it's a rapidly innovating space, like I compared it to the PCs. Rapidly innovating in both performance and cost. So as those performance and cost attributes improve, you transition from phones to laptops to golf cart batteries to power tools, and then you get into EVs. EVs, once those prices hit a certain point, it becomes more palatable, still priced a little bit more, but those prices are coming down a little bit with the transition from, like I mentioned a minute ago, EVs use a certain type of battery, utility uses another. I actually think EVs are actually transitioning toward that same battery type as they realize that they need to pull prices down. Tesla's Model 3 are going to start using LFP batteries, or what I'm speaking of. That's the future for Tesla Model 3s and others that are coming on as well. And China is predominantly LFP batteries as well. So as those prices come down, you start seeing a lot more use cases. And then you picture utility. I mean, utility scale storage, it is nothing but batteries. I mean, it has to be competitively priced. The performance has to be there. So just to dimensionalize this for you guys, this is essentially probably 1,000 battery cells bundled together in a 20-foot shipping container, placed on a solar site or placed on the grid to support the needs of the market. So that's transitioning quickly. The disappointing thing that we're facing, though, is ironically, LFP batteries were invented in the U.S. by a company called A123 that subsequently had some financial challenges, and their patents were sold to China. The rest of the world didn't think that that battery type was capable of being further developed, and China jumped on the bandwagon, and surprise, surprise, they have innovated LFP batteries to the point that they're incredibly competitive, and they're probably the future for lithium-ion batteries for the next 5 to 10 years. So what we're facing now is China, through some of the policies that Dr. Gaddy mentioned earlier, I mean, they subsidize the development of that sector, and they control it. I oftentimes hear the comparison that batteries plus solar probably and wind are the new oil, and batteries becoming more paramount in that. So if you take a slight sidetrack, solar and wind are intermittent. That intermittency can be managed on the grid today with some of those peakers that was mentioned earlier. But after you hit a certain point and you continue to develop more and more intermittent power supplies via renewables, that solar becomes more and more paramount. So battery growth's going to be pretty important going forward. So China's going to be an interesting scenario that we're going to have to deal with. I think what you're going to start seeing is more and more U.S. battery suppliers are going to have to form some type of partnership with those Chinese to get these plants up and running to support the growth that we need. And then there's going to be a real focus on innovation. The U.S. is going to have to get much more deeply involved in the innovation of those batteries to catch up and to be competitive in the future.
Jason, I know that we've talked about this, and I've had the pleasure of knowing you and working with you through the economic development selection process. So my role at Georgia Tech, we support economic growth, and by bringing the resources of Georgia Tech, the universities, in partnership with our other university colleagues in the technical college system, into conversations in support of economic growth, working with the Georgia Department of Economic Development and regional and local economic development agencies. So you mentioned earlier you were involved in the site selection. So walk us through kind of what was that process that led FREYR to select Georgia?
Yes, so we hired a consultant to help us, but the basis was we knew what we needed. We knew we needed a certain amount of land. Battery plants use a considerable amount of power. We knew we needed an adequate talent pipeline to support the growth. And we needed a good logistics position for us because a lot of these raws are going to be coming in from overseas for the start, but with a plan to build that out in the U.S. and having a good logistics location to support that, likely via rail. So that's kind of basically build an RFQ process that says these are all the things that we need. We sourced 130 sites in 35 states and narrowed that criteria down with a desktop evaluation to make sure basically what I just described was being achieved via those sites. As you proceed forward, it's narrow that down to probably 50 or so. We then put a quantitative lens on it that was more deeply engaged in talent. We knew what talent we needed. We were able to get what talent was available in the area, what was coming through the education system, what was listed through job portals and things like that, and building models. I knew how many incoming materials I needed. I knew how it was outgoing. I knew the energy demands, the energy prices that was mentioned earlier in Georgia is very important to us. So building that model narrowed us down to 6 sites across 6 states. Visited those, narrowed that down to 3 sites, and eventually made the selection with really the clear, the final. We really narrowed it down to 2 essentially, and the clear takeaway on the final decision was, Georgia is a great place to do business. I mean, 8 years running, I think, if I quote that right. 10 years running, depending on which area. 10
it was 8 when you were looking at Georgia.
Yeah, fair.
10 now.
Thanks for saving me.
It just gets better.
Yeah. So a great place to do business. The port of Savannah and other ports in the nearby area, the logistics, the talent. We were supported by, Greg, you coming in and helping us understand what tech had to offer. And University of West Georgia and the tech schools they have available to support our growth plans, and just working with the various parties that are going to help us be successful. To be fair, we haven't built a plant yet. We're still in that process, but understanding that we had the support of the locals and the state was paramount in really making that final determination for us.
I know you and I had talked about the direction of workforce development. As you all are looking at your plant, battery plants are much more automated than than we all might typically think. It's a pretty automated activity. So kind of when you guys are thinking about workforce development or talent, what's that profile look like?
Yeah, my experience is in heavy industrial applications, so much different. We have paper background, wood products, power, where you have operators sitting in control rooms pressing buttons and maintenance staff separate. Batteries are much more automated. It's automated and in clean rooms. Dry rooms has to be very clean. Don't want human hands in contact with anything. Safety concerns to some extent as well. And just tolerances are incredibly tight. I mean, incredibly tight tolerances in the microns as you're building these batteries. So profile we're looking for, at a basic level, we need troubleshooters. We need people that look for opportunities, help solve problems, because this is new to the U.S. We don't have a ton of, we don't have battery experts we can call that have been doing this for decades. So we're building it from the ground up. So we need problem solvers, troubleshooters, good collaborators. As far as the talent portfolio, I guess, it's predominantly 2-year tech degrees with heavy automation background. So robots, controllers, sensors, those types of things, because you're going to constantly have starts and stops. You need people that can help troubleshoot those. That's at the kind of the hands-on level. And if you go up to the next level, it's going to be more data. The data coming out of these plants, I mean, even if we build a new power plant today, the data would be far more advanced than it was in plants we built 20, 30, 40 years ago. So data scientists helping us understand the operations, how that operations feeds through to product performance, how we need to make tweaks in the process or the recipes to go forward. And then that translates to really material scientists, chemical engineers, material engineers, really helping us translate what we think we're seeing from the AI to lab scale experimentation, to bringing it back to the forefront, to my point earlier of innovating and really staying ahead of the Chinese.
You know, we have some of those scientists and engineers across the street. I'm just throwing that out. Yeah. But so what's interesting to me is a couple of things that you said. Let me maybe pull out a couple of those and highlight some things that are happening here in Georgia. So one from a science and data and information standpoint, beginning about 2 years ago, that there was we formed a statewide coalition called Georgia AIM, or Georgia AI in Manufacturing, and it's Georgia Tech, University of Georgia, Augusta University, Georgia Cyber Center. I'm going to leave some out. The Technology Association of Georgia, ATDC, our incubator, our statewide incubator, the Russell Center for Innovation and Entrepreneurship that's just around the corner here as well. A couple of regional activities in the Southwest Georgia Regional Development Center and the 21st Century Partnership there in the Middle Georgia region as well. I know I'm leaving a couple out, but one of those things, and the technical college system that focus on workforce development, technology development and technology deployment, specifically with AI tools and information tools for small manufacturers and large manufacturers. And increasingly more in we're seeing that more with the energy sector, with the increase in those areas growing fast. We're seeing that happening. And so this Georgia AIM coalition, it's working statewide, everything from introducing AI tools and concepts into K through 12, into the technical college system, and some wonderful programs that they're developing, into things with the university system, and then specific outreach by the universities that I mentioned as well, Augusta, UGA, and Georgia Tech. The other thing that struck me, which has been age-old and seems to transcend technology, is problem solving, working in teams, and critical thinking. And so I know that the Georgia Chamber has done a lot of different workforce development summits, and there's been a lot of that looking in Georgia, and what seems to be consistent routinely is that's always important. The technology advances, but the being able to work on a team and communicate and problem solve, that seems to be kind of the secret portion of that as well. Well, I know we have just a few minutes left. I've got some more questions, but let me stop to see if you all have any questions. Yes, sir.
I really appreciate your talk. I'm in the automotive recycling industry, so we're really front end of harvesting the feedstock. Thank you. So I know what the challenges are as we look down the road at 2030 battery demand, as far as how hard it's going to be. My question to you as a manufacturer is, what is y'all's anxiety over feedstock availability? And have you guys as manufacturers discussed solutions that maybe we on the harvesting side have not?
Yeah, great question. On the feedstock side, China has done a phenomenal job of subsidizing the development of that. So the LFP batteries that I discussed that they developed, they control 95% of the capacity of LFP batteries. They control 95% of the supply chain to feed those LFP batteries today. So supply chain in the short term will involve sourcing from China until the U.S. develops that feedstock capability. There are local announced companies that are landing here. Denkai's making foils here in the state. Inchem's making electrolyte here in the state. Novion has announced making anode down in Decatur County, Georgia. You've got Ascend, who is in Covington, that's going to be taking some recycled scrap and trying to clean that up so that it's able to be recycled back into the process. So feedstock-wise, there's help coming. Some of the federal policy is helping to subsidize that as well to get that up and running. So feedstock's a concern because in the short term, there's no way of getting around sourcing it from China. I feel fully confident that the U.S. will develop that, but there's going to be a huge demand on it. So there's going to be a lot of competition to get that. As far as the offtake, I mentioned Ascend. There's probably 10 other startups that are really focused on recycling battery waste. And I oftentimes hear in podcasts, oh my gosh, the Teslas, their batteries are going to die and you're going to have to recycle them. The problem's going to come much sooner than Tesla batteries dying. The problem's going to come whenever we start building plants. Our scrap rates at startup are going to be pretty substantial. So we will solve that problem before our plants come online through some of these startups that we're discussing partnerships with to solve that problem.
That's awesome. Thank you. In the back. Oh, excellent.
Great question.
Yeah.
I would point to Texas. Would be my first point. I mean, I think if they value the resiliency of the grid, batteries are there to serve that. Whether that be utility scale to support the residences, or whether it be behind the meter for commercial customers as well. The one other use case that I didn't mention that would be a concern as we think about distribution of energy going forward is as more and more EVs get placed on the grid, especially in residential neighborhoods, the demand in those residential neighborhoods is going to just skyrocket. So once again, it's resilient. If you like your EV cars, there's debate on who likes those or who doesn't, so I'll avoid that political drama. But the resiliency would be my comment.
Sir.
Yeah, kind of building on that question is we've heard today several speakers talk about the U.S. and the industry ahead of China's advances in batteries and energy. However, that seems counter to the messaging of some members of the government that are screaming from the aisles that this is an ESG hoax or climate change is not real. What is being done to counter that messaging, and how do we as business leaders get involved in that?
I'll pull a Dr. Gaddy and not get into debating if climate change is real or not. I mean, but I will say private industry is driving a lot of this. We are saying that we want to be a green battery company, so we're going to drive some of that, maybe not out of the gate. But I know a lot of the data centers are demanding green power as well. So there's a question on when's the economic threshold get met for solar being on par with gas peakers, or combined cycle, I should say, not gas peakers. So there's an economic storyline to be had. But more so, I think it's just the consumer demand. The consumers are demanding that they want green power. And that's, listen to the customer, let the customer drive what the value props are.
So I've got just a few seconds remaining, so I guess as the moderator, fellow fireside chatter, maybe make a couple of comments. You know, you always have a great conversation when there's still more left to talk about, and that's the case here. So Jason will be here in the area today, and so feel free to pull him aside and continue the conversation. I'll mention a couple of quick things. One, there is tremendous amount of battery and sustainability-related innovation and exploration happening here in the state with the university system, Georgia Tech, UGA, and others all looking at ways to advance that, both in the way we educate, the way we do research, and the way we commercialize technology. So I would encourage, if you have any questions, if you'd like to dive into that more, you know, we'd be happy to explore that. I'll add also, we've talked about partnerships, and Jason, we don't have time to dive into that deeply, but a lot of exciting things. You all may have a wealth of experience here, but in our conversation, Jason had shared with me that through the site selection and since selection, and as they've been activating here in Georgia, that they have been actively working with and establishing those partnerships with university system, technical college system, state economic development, regional economic development, and local economic development agencies. So we'd love to hear that. That's just a great reinforcement of why it's so important to be able to gather together and have these conversations. One final word, any final comments? Go Batteries, go Georgia.
Go Tech.
Oh, go. Oh, okay. All right. So that's always a good word to end on. So well, thank you very much.